Good day, everyone. Let's continue with our structure questions today. And today we are going to talk about something related to the heat of neutralization. Okay, you have already done. So now we are in the process of discussion about the answers. Now, a student carried out an experiment to determine the value of the heat of neutralization as shown in the diagram. Now, what are the substances being used in determining the heat of neutralization? The substance which is used is number one, I hope you can see clearly from your diagram, it is the hydrochloric acid, and number two, they are using the potassium hydroxide. Okay, now before we further move on, I want you to tell me about the procedure. About the procedure to determine the heat of neutralization. Okay, now can someone tell me? We are using the volume and concentration of this hydrochloric acid and the potassium hydroxide solution used here. So now I would like to get answer from you. Okay, who will be the first one to share your answer for the procedure to determine the heat of neutralization? Any volunteer?
Measure and pour 50 centimeter cube 0.5 mole per decimeter cube of hydrochloric acid into a polystyrene cup.
Okay, measure and pour 50 centimeter cube. We follow the question, 2.0 mole per decimeter cube. Hydrochloric acid, is it?
Yes.
Into where, Kachun?
Polystyrene cup.
Okay, polystyrene cup. What should be done next? Kachun, call a friend.
Yanjun.
Okay, Yanjun, what is next? Yanjun?
The initial temperature is measured and recorded with a thermometer.
Okay, so you are going to tell you measure and record the initial temperature of who?
Of hydrochloric acid.
You spell in full, Okay. Now what is next? Yanjun, call a friend. Yanjun, call a friend. Hey, no answer,
Measure and pour 50 centimeter cube of 2 mole potassium hydroxide solution.
2 mole potassium hydroxide solution or 2 mole per decimeter cube?
2 mole per decimeter cube potassium hydroxide solution into a polystyrene cup.
Okay. Polystyrene cup. Okay. Next, what to do? Some you call a friend.
GK.
GK.
Measure and record the initial temperature of potassium hydroxide.
Okay, the same thing, which is similar to number 2. Okay, what is number 5? Call a friend, GK.
Chia
Yuan.
Hydrochloric acid is poured quickly and carefully into potassium hydroxide solution.
Okay, pour quickly and carefully. into the potassium hydroxide solution. Okay, call a friend.
Maji Chen.
Stir the mixture using a thermometer.
Okay. Stir the mixture using thermometer. Any more to add? If no more, you call another friend.
And Yuan Kai.
Yuan Kai?
Teacher Yuan Kai not here.
Not here. Okay. Now I would like to hear from Tiben.
Jia Hui.
Jia Hui, Jia Hui not wake up yet. Jia Hui wake up already. Jia Hui wake up already. Tiben, next will be you. Jia Hui, come. What's your answer?
Wait.
Tiben first. Come, Tiben.
Teacher, highest temperature is recorded.
Okay, record. The highest temperature. Okay, is that all, everyone? Is that all?
Cover the polystyrene cup with a lid.
Or where should we add in cover the polystyrene cup with a lid?
Step 6.
Step 6. That means this one, the step 6 has become what steps?
Stir the mixture using thermometer and cover with a lid.
Okay, you cover first or you stir first? Shall I hear from Katnish? You cover first or you stir first?
Cover first.
Cover first. Who agree with Katnish? Please show me a light. Who agree with Katnish? A light, please. Okay, good. Very good. This Chen Jiahui is still sleeping. Okay, very good. Okay, now we cover first. So what should you add in? HCl is poured quickly and carefully into the potassium hydroxide solution. So here, number 6, cover the polystyrene cup with a lid. Okay, next, this will be number 7. Stir the mixture using a thermometer. Is this statement correct? Who thinks that this is correct? You show a clap. Who thinks this statement is correct? Show a clap. Or no one think it is correct. Or Jichen, sure Jichen will put a clap lah because she's the one who answer. Okay, now some of you never show a clap. What is wrong? What is left out? Shall we hear from Savish? Savish, what can you tell?
Stir the reaction mixture.
Stir the reaction mixture. Okay. Necessary or not the word reaction mixture? The answer is not. So stir the mixture using thermometer here is correct, but it is not accurate. How much do you stir? Do you stir it one time or you stir many times or you stir non-stop? Kajen, what should be added in here? Kajen? Are you there?
Stir the mixture using thermometer.
Start with the word. Start with the alphabet C.
Constantly.
No, constantly. Con also, but with a T.
Continuously.
Good. Stir the mixture using thermometer continuously. Then you record the highest temperature. Okay. So now I have a question now. What is the purpose of using the polystyrene cup? Who can answer my question? What is the purpose of using a polystyrene cup? We have not heard from Sangeeta yet this morning. Sangeeta, can you please tell me your answer? Sangeeta girl.
To prevent heat loss.
Okay, our friend said the polystyrene cup, this one, the polystyrene cup, it is to prevent heat loss. Do you agree? If you agree, show me a like. Oh, no one agree. Huh? No one agree with her. Okay, then why don't you agree? Shall we hear from Xiao Ying? What is the correction that should be done?
To reduce the heat loss to the surrounding.
Good. It is to reduce heat loss to the surrounding. We cannot prevent. Anyhow, it will still, some of the heat will lose. Okay, we are using the word to reduce heat loss or to minimize heat loss. I seldom use the word minimize because it might be more difficult for you to spell. So I will always use the word reduce. Actually, both of them correct. Okay, so this is the part on the discussion on the to determine the heat of neutralization. I hope you can write out this procedure on your own. Okay, now we are going to continue with our this question here. Okay, just now was what we have seen. Now the initial temperature we have recorded. Can you see the initial temperature of the HCl 28? The initial temperature of the potassium hydroxide should be 29. Okay, now what should be done when we want to do our calculation? We have two initial temperature. Therefore, we are going to look for the average initial temperature. Okay, now the table that you see from here is the table for you to record your observation. So let's say this question come out in the paper 2, section C, asking you to describe an experiment. Then you are going to put in this one as results. This one, I'm going to use the red. Your table, you put as results. Okay. Now this one all correct. You put the unit here. This one, just leave it. You can put this as theta 1, this one as theta 2. This one also the same. You put the unit. This one also the same, you put the unit. Okay. This one theta 2. This one you can put theta 2 minus theta 1. But then if I am putting theta 2 minus theta 1, it is not correct. Why not correct? Because we know that this is not the same. Therefore, we have to add another one part, which is the average initial temperature. Then you might put theta 1 plus theta 2 divided by 2 equals to theta 3. So your highest temperature, you can put this as theta 4. Then add another line, the temperature change. Degrees Celsius as well, theta 4 minus theta 3. Okay, this is how you tabulate your results. I hope you can understand until here. No problem, Okay, now next one. What is the meaning of heat of neutralization? We would like to hear from our friend Yuan Kai. He came late. What happened? Just wake up. Yuan Kai, what is your answer? The meaning of heat of neutralization. Can you please tell us?
Heat of neutralization is the heat change when 1 mole of water is formed from neutralization between acid and alkali.
Okay, now your answer. Now his answer is not wrong, correct? But you can write like this actually. What is the meaning of heat of neutralization? It is the heat change when 1 mole of water is released during the reaction between acid and alkali. Okay, this is your answer. Now, please note that you have to tell about the 1 mole, and the main character is the water. Now, next part, you are going to calculate the heat release during the experiment. I would like to hear from Mei Ying. What is the formula that you are using, Mei Ying? Mei Ying? Are you there, Mei Ying? Shakira, what is the formula that you are using? Are you there?
MC theta.
Okay, good. You are using MC theta. MC theta. Okay. Who can continue for me? What is used as the M? How much? You can just use your annotate and you write here. Use your annotate and write here, no problem. Okay, Lau Ka Chun write 100. Do you agree? Okay, I hope you agree. Now, what is the C? The C is this 4.2. Okay, now someone write for me, what is the theta? Annotate for me, what is the theta? Oh, 41.5, is it the theta? Minus 28.5. Okay, now final, what is the final? Final is 13. Yan Jun said, do you agree everyone? The final to be 13? Yes, okay. I'm sorry, Chao Yang, I erased this because I want to put the 13. Okay, so here the 13. Okay, someone unmute and tell me what is the value that you get.
5,460.
Okay, you are going to get 5,460. What is the unit, Alvin?
Joule, teacher.
Okay, good, the joule. Okay, this is your answer. Now we continue. Next part. Continue. The number of mole of hydrochloric acid, what formula to use? Shall we hear from our friend Chen Jiahui? What is the formula to use? Jiahui, where are you? Sawesh, what formula to use?
MV over 1000.
Okay, good. You are using MV over 1000. And someone tell me what is the number of mole that you get?
0.1.
Correct, 0.1 mole. Now continue. For the heat of neutralization, it is actually the delta H. Okay, therefore, you are actually taking the delta H equals to the 5,4 that you get now, the 5460 joule is actually 5.46 kilojoule. Okay, so here you are taking the 5.46 kilojoule divided by the 0.1 mole, and this is delta H, so don't forget to put your negative sign. Why negative sign? Because it is heat, the temperature increases. Okay, now our final answer, I hope you get it as negative 54.6 kilojoule per mole. Okay, please make sure you have your unit written correctly, kilojoule per mole, and the negative sign is there. Okay, everyone can follow until here? No problem, Okay, now we continue. Next part. We are now going to draw the energy level diagram for this reaction. Now, this is the part where in the exam that day, many of you have problem to do so. So now I am going to show you one more time for the drawing of the energy level diagram. Now, first of all, we must have an arrow. Okay, this arrow. Now, what is the title for this y-axis? It is actually the energy. Okay. Now we are going to have two lines. What type of reaction is this? Someone tell me, exo or endo? It is an, yes, exothermic reaction. So therefore, we are going to have our line going down. First line, okay, and second line here. The line will be going down. And you are going to show the arrow coming down like this. Okay, touch. Okay, sorry. Touch like this. Okay, next. We are going to write our equation here. Okay, so before you put it in here, you have to draft your answer first. What should be your equation? So in this case, no problem for us to do because we know that the ratio is 1:1. And our product will actually be the KCl and the H2O. Now, for the delta H, please put it at the center here. For the delta H, for the delta H, you are going to put it here. Equals to negative 54.6 kilojoule per mole. Don't put it up, don't put it far. It should be at the center. Okay? And one arrow from my diagram, can you see this part? It does not touch. You have to make it touch. Okay? So this is your answer. Are you okay with this? Who get all correct? Show me a love if you get all this correct from your answers. Okay, good. Who else? Wow, very good. Good. Okay. Good. Jiahui, you are still not there? Chia Yuan, which part you didn't get correct? Chia Yuan, which part you didn't get correct? Okay, now we continue for the next part of the question. The experiment is repeated using the ammonia solution to replace the potassium hydroxide solution. Now, meaning to say just now is a strong and a strong. Okay, Chia Yuan Yan Jun is asking if she writes an ionic equation, can or not? What do you think? I will ask our friend to answer you. I will ask teacher Alvin. Teacher Alvin, is she correct if she's putting ionic equation?
Sure, the chemical equation and the ionic equation is the same, sir.
It's the same, so can or not?
Can, sir.
Can, correct. Teacher Alvin said correct. Yan Jun, the answer is yes. And make sure your ionic equation you write correctly lah. Now, for those who want the ionic equation, this is the one. Hydrogen ion reacts with the hydroxide ion to give you H2O. This is correct for all the neutralization questions. Okay, now come to our question here. Okay, now the experiment is repeated now using the ammonia solution. Ammonia solution. Initially, we have this KOH and HCl, where it is a strong and a strong. Now, we are now going to use the ammonia solution, NH3 or the NH4OH with the HCl. And from here, from our previous lesson, we know that this is a weak and a strong. Now, the heat of neutralization using the ammonia solution is lesser than the heat of neutralization using the potassium hydroxide solution. You are now going to explain the difference in the heat of neutralization. I would like to get the first line of the answer from one of our friends. Who volunteer to tell your answer? Should we listen to Yan Jun? Yan Jun, what is your answer?
The potassium hydroxide solution is a strong alkali, while the ammonia solution is a weak alkali.
Okay, who agree with this? Show me your hand. Show me a like if you agree with this. Okay, good. Good. Which color? What color? Okay, this one is a weak alkali. Now, what should be the sentence that we are going to talk about it next? Who volunteer? When you are writing this, you get 1 mark already. Now, who volunteer to tell me the next sentence? Who?
Potassium hydroxide dissociates completely in water to produce high concentration of hydroxide ion, while ammonia solution dissociates partially in water to produce low concentration of hydroxide ion.
Okay, good. This is correct. But in this case, when you are given only 2 marks, this sentence that you mentioned will carry the same mark with the sentence just now, the strong alkali and the weak alkali. What is the next sentence that we are going to talk about? And I have already mentioned about this sentence many times. I said when we talk about heat of neutralization, this sentence will sure be one of the answer. Start with the word sum of the heat. Continue, someone. Shakira, can you tell us your answer? Sum of the heat energy.
Release is used to overcome the bond of is used to overcome.
Okay, that one you confused with this naphthalene experiment. Now, in the naphthalene experiment, later I will give you the sentence. But for this part, sum of the heat energy is do what? Is reabsorbed or is absorbed back. To do what? To further ionize the ammonia molecules. Okay, I have mentioned many times this sentence must be there. This one must remember. Show you many love so that you remember. Next time when I ask, you please give me this sentence. This is being mentioned many times already. Okay, now for this Shakira's answer, I will give you later. I will like to finish this part first. Another material that can replace the polystyrene cup, what can you use? You are going to use what? You can use a plastic cup, okay? Or if you are asked to suggest another method without using the polystyrene cup, what are you going to use? You are going to use the polystyrene cup. You cannot change to plastic cup. So what can you do? You can double, use 2 polystyrene cup, or you can say you are going to wrap the polystyrene cup with cotton wool. Can also. Okay. Now come to the question where just now like Shakira said, for the question on the heating curve. Mine one is not a good drawing. Okay, this is the heating curve. Now you see, you will find that at this part, the temperature remain constant. Okay. Now, why is it so? Your answer? Your answer is some of the heat absorbed, some of the heat energy absorbed is used to overcome the force of attraction between particles when changing from solid to liquid. Okay, now we are not going to say overcome the bond as what Shakira said just now. Now you see the keywords of our answer here: heat energy absorbed. What is used to do? Overcome the force of attraction between the particles. Must have the word particles. What is happening actually? Oh, the substance change from solid to liquid. Okay, this is the important part of the answer. Okay, this is about the heating curve. If we are talking about the cooling curve, then we are saying that some of the heat energy is released, is exactly balanced by the heat energy released to the surrounding when the particles attract each other together to change from liquid to solid. Okay, please check the answer for these two parts and remember the sentence. Okay, before we continue, any problem? Any problem with this? No problem, okay. Now, if you have no problem, then I think I will stop our lesson today. You don't have to log in the first link. You don't have to log in the second link. Okay. We will stop our lesson